Now that we know how to solve trig equations, we're going to look at two equations now that go back and use some of our sum and difference identities in them. Okay, so for number one, we have the cosine of x plus pi fourths plus the cosine of x minus pi fourths equals 1. So we're trying to find the angle that we could put in the x spot here that would make this equation equal 1. Because I'm taking the cosine of a sum and the cosine of a difference, I am going to need to use those sum and difference identities. So you may want to pull out your identity sheet, and I think I have mine here that I can put out here to help you see the identities. Okay, so remember I can label u and v on both of these. Cosine sum is right here, so this is cosine u, cosine v, so this would be cosine x, cosine pi fourths, minus sine x, sine pi fourths, plus, okay, now I'm going to use my cosine difference identity, so I'm going to switch to this one, cosine x, cosine pi fourths, plus sine x, sine pi fourths. Okay, now this is not a proof. Remember, I'm actually solving this equation. I'm trying to find the x value that works. What we want to do is go ahead and see if we can simplify anything, and then we're going to plug in our unit circle values. I noticed that right here I have a negative sine x sine pi fourths and a positive sine x sine pi fourths. So those can completely cancel each other out. And then these two here are the exact same thing, cosine x, cosine pi fourths. So I can combine those and say that I have two of those. So 2 cosine x, cosine pi fourths has to equal 1. Okay, so I've got it simplified. Now I can use my unit circle to replace that. What is the cosine of pi fourths? The cosine of pi fourths is square root 2 over 2. So I can just replace that. Now, this is just a number just like this 2 out here. They're separated by a cosine, but I can still cancel this 2 with this 2 in the denominator. It may make it easier for you to see it if you wrote it like this. This 2 cancels this 2 out. Okay, because that square root 2 over 2 is not part of the x that I'm taking the cosine of. It's not part of my angle. It was a whole separate quantity. So I can just move that to the front, cancel those out, and I'm left with square root 2 cosine x equals 1. And now it looks like a really simple equation. I can divide both sides by square root 2. And then rationalize this out. I get square root 2 over 2. So all I really need is, where is the cosine square root 2 over 2 at? And that's easy. It's in quadrant 1, pi fourths. Quadrant 4, 7 pi fourths. And I don't have a weird period or anything because I don't have a value in front of my x. So I don't have to go through and add my period. It's just those two answers. All right, let's look at number 2. I'm going to kind of set it up the same way. U and V here, U and V here. I'm going to use my sine sum identity first. So sine x cosine pi fourths plus cosine x sine pi fourths. All right, plus, now I'm moving over to this one. This is my sine difference. So this would be sine x cosine pi fourths minus cosine x sine pi fourths. And our equation has to equal -1. Okay. So let's see if we have anything we can simplify. Just like the last problem, it's going to work out very similar. These two are the exact same thing, except this one's positive and this one's negative, so I can completely cancel those out. These two are the exact same thing, and they're both positive, so I can combine like terms here and make that 2 sine x cosine pi fourths equals -1. And again, I'm going to use my unit circle to simplify that. The cosine of pi fourths is really square root 2 over 2, so I have 2 sine x times square root 2 over 2 equals -1. I can just take that, since with multiplication, order doesn't matter, I can take that and just move it here so I can see that it cancels out. Okay, so that's what I have. My 2's are going to cancel. So I have square root 2 times the sine of x equals -1. I'm going to divide both sides by square root 2. So sine of x equals, I'm going to rationalize just like I did the last problem. So these are turning out to be very, very similar. Negative square root 2 over 2. So where is the sine? Negative, quadrants 3 and 4, square root 2 over 2. Okay, so that would be 5 pi fourths and 7 pi fourths. I don't have anything sitting in front of my x, so my period is the normal 2 pi, so I don't have to worry about going back and adding anything. So those two are my solution. And just remember, you can always check by putting your calculator's answers back into the original problem. Just watch your parentheses and see if you really get -1, which you should.